Good morning and welcome to Making Space for the Internet of Things. If you have questions for the speakers during this session, please enter them into the chat feature. And now we are pleased to welcome our moderator, Tom Soderstrom, Director of Lead Architects for Amazon Web Services. Tom?
Yes, thank you for joining us today. And I'd like all the panelists to go live so you can see their pretty faces. So what we're going to talk about today, it's the beginning of a journey. And if you look at, why are we having this panel? So I'm Tom Soderstrom. I was Chief Technology and Innovation Officer at NASA's Jet Propulsion Laboratory for the past 14 years. I now work for AWS, Amazon Web Services, where I am the Director of Lead Architects. Why do we have this panel? So briefly put, there is the IoT, Internet of Things, and space are both projected to be a $1 trillion business each. So with law of exponential return, how big of a business will this be? Well, it certainly will be big, but it's more than dollars. So it's an opportunity for everyone. It's the synergy between IoT and space. Space is the ultimate frontier, famously said by Star Trek. And so as you push things to the edge, you're going to push things to the edge. It's just not sensors, it's entire spacecraft, perhaps entire cities. And you're going to push the communication and take that back to Earth to benefit humanity. So it's the synergy between the two. It's the flow back of breakthroughs in space. When you innovate at the edge with constraints, a lot of it comes back to Earth. It's going to benefit all of humanity with communications, and most of the satellite growth is for communications right now. But it's also about science and huge business opportunities. It'll be less expensive for space agencies, and there are many, many coming up from many countries right now to generate a return and go into space. Large system contractors will be able to do a lot more for less. Startups can participate. In the Exponential Organization book, the idea was that you don't have to own anything. You can just participate. So the barrier to participating is much lessened, both in terms of data. It's going to be much, much cheaper to calculate, take it down, etc. Individuals like a few billionaires will participate. Educational institutions will now get hands-on experience with both science and robotics in space. Countries will collaborate much better. I don't think there's a better ambassador than space because it affects all of humanity. And then public-private organizations will participate. So it's the growth, just a little quick on the growth here. It's now arguably, but I've looked at the data, on the average 1,000 times cheaper to build a spacecraft. It's 6 times cheaper to launch it. It's orders of magnitude cheaper to store it and calculate on the data in real time. If you look at the investments in space companies, it grew twofold to $1 trillion. I'm sorry, to $1 billion between 2018 to 2019. So that's why we're going to be looking at this. It's the beginning of a discussion. Now in this, there are some challenges, and we have this august panel to talk about it. So how does translating IoT on Earth going into IoT in space? And I don't know if we have Deborah Lamb on yet. Deborah, are you on?
Yes, I'm here.
Oh, good. So Deborah is an expert in IoT on smart cities and also public-private partnerships. So Deborah, if you can talk about the growth of smart cities and anything else you want to tell the audience about.
Yes, thanks, Tom. Thank you for having me. Yes, so I am the non-space expert and more the person on the ground working in cities to start with the foundation. And what we're seeing with cities and communities, both locally, nationally, and internationally, is a shift in terms of how they operate. So traditionally, cities were in charge of physical infrastructure. nuts and bolts, roads, highways, traffic lights, garbage pickup, just the nuts and bolts of physical infrastructure, which was very clearly defined. They were in charge of a geographic area, and all the infrastructure within that geographic area, more or less, from public policy to operations to budget, etc. Now, those levels may vary within cities, but more or less it was understood what the city had to do in terms of operational efficiencies and delivering services to citizens. What's gotten a little more tricky is when we add a second layer of infrastructure, which is what Tom alluded to, the digital infrastructure. So once you have the physical infrastructure, which was very clearly defined, is then you add the digital infrastructure and those connections, what we call IoT, is who's actually in charge of that digital infrastructure. Who's in charge of the data, who's in charge of ensuring that there's proper connectivity and digital infrastructure is actually operating and in some cases connecting to the physical infrastructure. And then that third layer, which is the social infrastructure, which is how people operate within the physical and digital infrastructure. So this is what makes IoT and smart cities still to be defined, to be determined place, where cities no longer have that set geographic boundary like they do with physical infrastructure to determine public policy, to determine operations and budgets, because of the complexity of the digital layer on top of the complexity of how people operate within the physical and social layers or digital layers. And so what's happened is that there's some demonstration areas or some verticals that are making huge strides within the city. So they might allocate a certain area to try to test those three layers working together. Or there might be a vertical, particularly around mobility, that they can isolate and move forward. But it's still being built as we speak from on the ground smart cities IoT perspective. And so I would then take it to the next level is when you have still things on the ground that's still being defined in terms of standards and operations and enforcement, how does that translate to the space opportunities that Tom was alluding to? And I'll leave it at that there.
Thank you very much, Deborah. And so what we're doing is we're basically going from the ground up to space. So thank you, Deborah. Then you mentioned standards, and there's going to be a lot of satellites out there, lots and lots of them, as we've heard. Walt Everett is an expert on this from Iridium, and so we want to understand, how do you manage many satellites in space and all the things that go with it? Walt?
Well, thank you, Tom. And I want to thank the AIAA and the conference organizers for the opportunity to speak. It's really, I like to use the term enabling. So what Iridium does today is it enables a communication capability. As Deborah just discussed, you have smart cities today, much different than the infrastructure that was apparent and useful 20 years ago, 50 years ago. Now we're moving more into a digital and a smart city age. So how do we use the space infrastructure to do that? And that's where kind of Iridium is on the forefront of that. We provide that communication backbone, that communication capability in order to stay connected everywhere. So if you then take that current situation and kind of project ahead, the first thing that we know is we don't know. We don't really know what the business case, the utilization case, the consumer needs will be in the future. So we have to start thinking in terms of how do we enable a capability that we don't even know what that capability is. Standards is certainly important. Security is certainly important. Reliability is certainly important. I think what we need to start to think through is is more of the model of you have a standard way of communication or standard packetized communication capability, and that can be enabled by multiple platforms. It could be Iridium. It could be, a point-to-point. It could be based upon Earth to Mars. It could be based upon a tug to the moon. And if you kind of expand the Iridium model, which is, you can talk anywhere, any time, any place on Earth, and to all of those smart connected cities that Deborah spoke about, and then apply that type of lessons learned and that way forward to enable communication. So again, back to the crux of the problem, it's not so much knowing what the consumer or the business needs will be, and I think it will start at a single use or a single use case, and probably based upon governments or non-commercial entities. And how do we then just make sure that enabling capability will move forward to drive more innovation, drive more business, drive more capability, and it's true. Then you will get a lower cost, and you'll get a more substantial capability, and you'll get a secure capability. So it's really all about where we are today, how we're going to drive to what we think will be a platform capability, and then again, I think the business will drive what that enabling capability will enable. Whether that's tugs, or that's on Mars, or that's satellites and rockets and all kinds of very interesting things that we just don't know about. The one thing I do know is that in the future it will be much different than we have it today. And I think what Tom just mentioned, and I'll end with, is that kind of standardization, and how we need to make sure that packet, that consumer packet, can get from point A to point B, wherever that happens to be, on multiple different platforms, multiple different smarts, multiple different applications. And I think what we need to do as a society and an industry is how we can enable that delivery based upon what the consumer needs will be. So I hope that helped. I hope that gave you a perspective of a established owner operator where we need to be. And I'll hand it back to you, Tom.
Oh, that's terrific, Walt. Thank you very much. And I'm sure there'll be lots of questions from the audience, and a couple of prepared ones. Great stuff. DARPA is an organization that always innovates literally at the edge. Now they're going to innovate at the edge of space. And Stephen Forbes is here to talk a little bit about that, about what's happening with some exciting innovations. So Stephen.
Thank you. So I'm the program manager for the DARPA Blackjack program. We're attempting to proliferate across space for the U.S. government. And it's interesting because you could almost make the argument that this is, technology has finally caught up to some of the visions. Iridium was sort of there first, as far as a proliferated constellation. I think technology and the DARPA Blackjack program, plus what SDA and the rest of the government is doing on the government side, is showing how we can proliferate, and really start pushing, the numbers up from under 100, and we'll go into hundreds and thousands. And you can look at what SpaceX and Amazon and OneWeb and all of the commercial companies are doing. And it's interesting because from my perspective, the Internet of Things in a terrestrial sense is enabled by connectivity, is enabled by sort of some fundamental underlying infrastructure. And I think that, for that to happen, for the Internet of Things to expand into space, that infrastructure in space needs to come. A lot of the approaches will be the same, but there won't be a direct, the same standards working. So how we do, connectivity, how we do communications, to Walt's earlier point, how we provide power, and really how we provide computing resources in space is what's going to either enable or prevent this growth of Internet of Things in space. From my perspective, when you're in low Earth orbit versus other orbital regimes, I think we can certainly provide both the connectivity and the computing. And so I certainly see the future proliferated constellations is really enabling that Internet of Things. And we'll just have to see if technology allows us to proliferate and push that Internet of Things out of low Earth orbit, to the moon, to Mars, and beyond. So Tom, back over to you.
All right. Well, thank you very much. I appreciate that. Again, DARPA is always innovating, so it'll be really fun to see what comes out of it. The next thing is, once you are out there in space, you have a lot of satellites, and there's a lot of satellites. I just looked at the data. The oldest satellite still out there is from 1958. How about that? It's not operating anymore, but it's still out there. So that's something we're going to have to talk about at some point, all the stuff in space as we put more, thousands and thousands of more up there. And DARPA, I'm sure, will come up with some interesting standards there. So now, once we're in space and once humanity is establishing a longer term presence in space, what does autonomy look like there? And we have the great honor of an astronaut from UC Davis here. Steve Robinson is working on this. So Steve, would you give us a perspective?
Good morning, Tom. Hello, everybody. Thanks for inviting me here today. I've already learned a lot, so I've got enjoying the panel. I'm going to talk about human spaceflight, just like Tom said. And the future of human spaceflight includes, following up much of what Deborah said, smart habitats. So these are habitats that are either orbiting in microgravity conditions, in transit to a distant destination in microgravity, or on some partial gravity surface. And these smart habitats are considered to be intermittently crewed. So people would only be on board 2 to 3 months out of 24, something like that. It's, so most of the time operating by itself. So this is new territory for NASA, almost new territory. Most of the experience right now is 24/7 crew presence plus mission control, also 24/7 support and control. This is a highly brittle, lots of hands-on, lots of brain power to keep a vehicle like the ISS operating every day, every hour. It's been very successful, coming up on 20 years here. Or the NASA experience has been fully robotic, highly automatic, somewhat autonomous, deep space probes and rovers. These have been very successful. They tend to be inefficient compared to what humans can do, but so far highly reliable. And then a little bit of experience way back in the 70s with Skylab, where America's first space station was uncrewed for a few weeks at a time. So this is really a new class of vehicle in the modern age, and this habitat has to be self-sustainable when people aren't there, and to be able to sustain human life when people are there. So what model should we be thinking about here? Do we think about it like Mom's house, where you go and visit, and she could do the basic upkeep, but you waits for you to arrive to do any kind of repairs that are beyond like replacing a light bulb? Or should the model be more like your vacation home, where you shut it down, place it in hibernation all year, except for the 2 weeks in summer when you go back, and you spend almost the entire 2 weeks doing repairs? Should it be a combination of these two? But really, no, it is clear it has to be a completely new model, made possible by dense and reconfigurable sensors, which you might call IoT networks. But that is, these sensor systems have to be paired with onboard learning systems, telemetry to mission control, autonomous systems that learn from and team with both the astronauts on board and distant support teams that are asynchronous, but potentially with dropouts and long comm delays. Also required to do any kinds of maintenance and repairs and reconfiguration are advanced robotic agents, also team with humans, onboard manufacturer of replacement parts to the extent possible. And so when the crew arrives after a long period of nobody being there, there's a deep state of knowledge about the vehicle, what the humans can and should do. And there's both machine learning and machine teaching as an essential part of the success of a smart hab. So to explore the technology that I just talked about for this new class of spacecraft, NASA has funded 2 major space technology research institutes in the last year. The idea is to identify the key problem areas and the enabling technologies to address the requirements that I just mentioned. So these 2 institutes are RETHI, the Resilient Extraterrestrial Habitats Institute at Purdue, and the HOME, Habitats Optimized for Missions of Exploration, led at UC Davis, includes 7 universities, and each of these is a 5-year NASA-funded project, so it's a pretty big deal. In the HOME Institute that I lead, there are 3 major research areas. First is vehicle self-awareness. This is kind of like the smart cities. Transported to space, you have advanced sensor systems, IoT tech, intelligent analytics to enable subsystem and component degradation prognostics. So that's state estimation and state prediction of the vehicle. The second main research area is human autonomy teaming. So that whole big world of supervised machine learning for response to both the routine events that you always have in a spacecraft, which, by the way, when you're in a serial number 1 of something, there's a lot of things that you think are going to be routine and they don't turn out to be that way. I've got lots of experience with that. And the third category of research is vehicle self-sufficiency. So we have intelligent robotics teamed with humans, either locally or distant, to accomplish the maintenance, repair, and especially anomaly response to events that have been unexpected and initially not understood. So we're just completing year 1 and 5. Hopefully you'll hear much more about these 2 space technology research institutes from NASA. So thanks, Tom.
Thank you very much. It's very exciting. I love the acronyms. NASA is great for coming up with acronyms. HOME.
Oh, no, we did it. Of course, we're all ex-NASA people, so I guess we learned it there.
Yeah, I think we all learned that lesson. But you brought up 2 to 3 months in a very inhospitable, cold place. I mean, you've experienced it more than any of us have. And so how do you, for future space travel and future habitats, how do you live in such a hospitable place and stay sane, and also have a robotic helper, as you also mentioned, to help you out? So Liesl Yearsley is the CEO of Akin, and she's joining us from Australia today. And she's an expert on personal AI. So Liesl, would you talk to us a little bit about that?
Absolutely. It is not often that I get to talk about the very, very abstract coupling together of IoT and terrestrial smart cities and smart homes and space habitat. So I'm truly excited. I actually, as Tom said, I build artificial intelligence systems. I've been in the field for about 20 years. So my previous company was actually acquired by IBM and it became a very big part of Watson. I then worked at Watson for a while, running Watson Life, and I founded Akin. We spent about 2 or 3 years doing deep tech research, figuring out a novel approach to AI, something that's able to reason more intuitively and have better understanding of humans. And we very much take it into habitats. So for us, space has been the most wonderful playground to work in. We've just been awarded a very large grant to build out AI crew for space. We're putting them initially in clean rooms, helping people build spacecraft, but the roles we envisage are going to very much mirror what will be needed in a space habitat. So we're looking at a helper that helps with complex tasks, a manager that understands the habitat as a whole system, and inspectors that gather IoT data and do something with it. So why do I think the 2 live together? And why do I think, most importantly, there's a lot of opportunity for private organizations to do a lot more in space than we could ever dream of it back in the 60s when we did the first moon landing. You know, if you think about a space habitat, it's a tin can or a can with, you know, regolith on it, however it ends up being built. Inside this tin can are monkeys, you know, primates with feelings and emotions and good days and bad days. And they're forming this weird little family. I haven't been in space like Stephen, but from what I understand, astronauts are very carefully selected, but they're not a typical family group. And there's tasks to be done, and there's resource constraints, and there's environment to think about. So if you think about it, for the first time in human history, We get to build a society from ground zero, from the ground up, from nothing. We get to put humans in an environment, and we get to put them in collaboration with AI, and the AI and robots might well outnumber the humans. We get to see how to do it well, and then translate everything we learn back to Earth. So we're just very excited with what we're doing. And we have 3 key research areas that we're working on. The one is, as Tom mentioned, personal AI. We're talking about deep emotional IQ. We're not just talking about sentiment analysis, but really understanding core drivers of humans, and how we construct ego models, and then our own world models and other models, and how they all fall together in the real world model, and how we iterate towards state using these models. So we have a novel approach to deep human awareness. The other one is habitat as a complex system. So you now throw these individuals with their individual models into an outside model, and the whole system needs to get to a certain state. Our third area is collaboration on complex tasks. So initially, we're just going down the path that's been trodden before, where how does an AI and a human work together on complex tasks? But we are working towards more autonomy, because out on the edge, you can't call back to Earth to answer everything. You can't just rely on brute force machine learning and a lot of cloud data. Sensors and IoT become your eyes and your ears, and you have to make more autonomous decisions. So I really do think we're going to be relying more on human AI teaming. On Earth, before we were acquired by IBM, we were running about 60 million interactions. We had about 26,000 external developers using our platform. So I got to see a lot of human-computer interface. People form a bond with these more than anyone realizes. They can be exquisitely fine-tuned to human emotions and human capability and human state. They can remember more than we can. They can support without overriding. So I think there's great potential. And for anybody who's listening, who's not in a space agency, who wants to do something cool, space is actually within reach. You can go out there, you can get investment, you can actually go build something cool, and you can actually get to benchmark it. We might not all end up on the moon or on Mars missions, but space is so much more open to private partnerships than ever before. And I think that's extraordinary.
Thank you very much, Lisa. That was great. So I think what you're hearing here is a theme of hope, a theme of this is a new playground. It's a new, we'll see new companies form that we've never seen before. We'll see very interesting private-public partnerships, and that's one of the areas that Deborah is an expert in, so we'll come back to that. I want to take one question from the audience that came in that I thought is quite interesting. The question is, will future data platforms be space-based or rely on ground-based communications stations to operate efficiently? And what does the phasing look like? This is some area I've spent quite a bit of time on. How do we, so if you have all these satellites in space, and of course, we're talking about near Earth orbit so far, but it's going to go into deep space. How do you communicate? There's a lag time, there's going to be radiation, there's all kinds of things. So if we start with where is the data? I think the data will be a combination of Earth and space. I think that once you get into deeper and deeper into space, you're pushing the edge, so you can't afford the lag time. It's 15 minutes or so from Mars, so it has to be autonomous. But if you could put a data center on Mars, think cloud computing pushed out to the edge, you could do a lot more. So I think we'll see that. I think we'll see a lot of communication back to Earth, especially for near Earth things. And I wanted to ask Walt to talk a little bit about that as well.
Excellent question, Tom. And I think, like you just mentioned, it doesn't have to be one or the other. I think it's going to be a combination of all. And if you think about communication capabilities, some of it will be ground-based, some of it will be space-based. And I think you want to be able to enable those multitude of different applications across the board. One of the things that I've been thinking about is, where does the smarts go though? Does the smarts reside in your more traditional satellites or your more traditional ground stations, or do you really drive the smarts of the the product or the smarts of the communication need down to the product. And by that I mean if I'm a sensor, I'm on a tug, I'm autonomous, I'm self-sufficient, I'm something that we haven't thought about now is, do we put the smarts on that unit to say, I need to send this packet of data to X and make that product the smartness, and think about, well, how would I do that? I might relay off of a Mars location. I might use, for a low latency, might use something different than a high latency. So I think it's kind of a combination of all of those things. And I think the real question becomes, where do you put the smarts of that communication need? Thanks.
Good. Thank you. And one of the things that's a common theme here with IoT also, I'd like to ask Deborah about this a little bit, but it's pushing the smarts to the edge. So you're having machine learning running at the edge in these tiny devices on Earth. When you look at 5G, for instance, it's really pushing the speed out and farther. When you look at 6G in the 2030 timeframe, it's going to be all the calculations happen at the edge in the device. Deborah, what are you seeing on this, where the data flows and how it works on Earth in smart cities?
I see the biggest issue around privacy and security, in a sense that we haven't quite figured out how to have a common definition about what type of data is private and secure and confidential, and how to fully utilize that data that's fair for not only companies and cities to use, but also reflection of the citizens that data belongs to. And you've seen a lot of eruptions happening at the city level when we start talking about data and the application of data, and who's actually going to be monetizing the data or using that data, and for what purpose. And the scars that we are seeing from smart cities is when those standards and that foundation isn't transparent from the beginning, and it's not fully understood by everyone that's involved. And that's where, actually, if you don't have that strong data foundation, it could really upset the larger plans and strategies of smart cities, because that becomes the main focus, if you will, versus all the other IoT benefits that could come when you do, technology advancements and efficiencies and autonomy. We're very focused on, that data and the potential of that data right now.
Good. No, thank you. And as you talk about data, and one of the opportunities here is we're going to have these thousands of satellites all creating different data. And I want to ask Stephen from DARPA about standards potentially, and security, and how will this data, if we can't use the data, it's pointless, and you're going to get all these point solutions that don't collaborate. So do we see standards coming, and what about security? Stephen, are you comfortable answering that?
Sure. So I think standards, just like they are in the terrestrial sense, going to be absolutely crucial to enabling this future. To a large extent on the terrestrial side, standards are enabled by volume. And right now the space industry doesn't have a lot of volume. And sort of the analogy that I see is, in the early day of computing, companies were interested in trying to grab as much market share as possible, and so interoperability was low on the priority queue because it would actually make it easier for their competitors to compete with them. But as the volume of computers sold went up, being able to be interoperable became a plus to have when you were trying to sell your product versus a negative. And I think if space truly expands, you're going to see the same thing. So, in the next couple of years, I don't see any business case that will say SpaceX and Amazon want to make their satellites interoperate such that I, as a user on the ground, or I, as a user in a spacecraft, could, seamlessly hop between them. But I think if space continues to expand on its current trajectory, that will essentially flip. because now essentially that will become essentially a possible revenue stream for them to provide those communication services more seamlessly than essentially trying to own the entire business segment. You know, with that, you have to have a way of doing that securely. You know, if your data isn't secure or interoperable, the value of that data goes way down. You know, security is a challenge in terrestrial applications, and I think you know, the same challenges will exist in space. I'm not sure from where I sit that we have really great solutions to the security problem. You know, doing security right is expensive and hard and time consuming, and all of that sort of works against you know, the ability to get a product out the door at a time frame that the consumer actually wants it. And I think that pressure is going to remain in space as well. So thank you.
Okay, no, thank you. This is an interesting question, of course, and as we just heard, volume is key. And volume is not going to be a problem. The satellites going up from all of the communications, I looked at the data, half of all the satellites that are coming are about communication, at least half. So it's about extending the reach of internet into places on Earth where it doesn't extend. And there are thousands coming. So volume is going to come. Interoperability is something we should push for. And Iridium, are you looking at interoperability here, or how are you looking at this problem?
Well, of course. I mean, and Stephen said it. Yeah, Stephen just said it accurately. It's you know, you take the analogy of the terrestrial system, and you know how at one point in time being interoperable wasn't necessarily an advantage from a business perspective, and then as the technology and the consumer evolved, being interoperable was absolutely necessary, and you see that today in a lot of different applications. So, you know, certainly Iridium is thinking in terms of standardization, security. You can't think in terms of delivering data that's susceptible anymore. You have to think in terms of very secure protocols, very secure capabilities, and you also need to think in terms of what does that consumer want, which is always, you know, we want to protect our data. So, you know, back to the question, interoperability, absolutely. I mean, Iridium is thinking about that today. They're thinking about how we can take the next generation and build upon what we have today, help develop standards. There's some standards out there today, and kind of be a part of the solution, the relay solution, the transport solution, the enabling solution that I spoke about. So absolutely, I think we all have to think in those terms.
Good. So thank you. I know JPL and open source has extended internet into space. So that's another, all of a sudden, these things aren't just little sensors, they are entire spacecraft, perhaps entire cities. Perhaps you could build a data model, a digital twin of a city in space, call it city lightly here. An interesting question came up about the idea of the mom's house and the vacation home in hybrid. And I thought that was, you know, we explore on space, we take our human experience and we push it into the edge. Does anybody want to tackle that question? How would we go about doing that?
I vote for Lisa to start, and I'll follow up.
Okay.
So the question, as I believe, is we were going on the analogy of mum's home and vacation home, and are the robots just sitting there puttering around, cleaning the mold off the walls while the humans are not there, or are they really there to be part of the family? My feeling is we should shoot straight for a hybrid. There's no reason we can't do both. Yes, certainly it's easy to think of robots moving around an uninhabited environment, cleaning things, but often the biggest risk in long duration voyages is the humans themselves. You know, we're pretty buggy compared to robots. We decay, we fight. You know, I look at my teenage son's bedroom if I don't put my head in the door for a day, and it turns into a rat-infested pit. You know, so humans are messy. We transition poorly from one to the other. You know, a lot of the problems that I understand in space stations are leaving things lying around and people not getting on or doing their jobs. So it's not as hard as we think to actually make a robot have a personality that people find plausible. Families and working groups need roles. They need people, somebody to be grumbly. They need somebody to be cool and collected and focused on the task at hand. We all have Alexas that we talk to, you know, we all have Google Assistants that we talk to. Attribution of personality is a natural thing. You know, even if they were just taking simple roles like being a sounding board and checking in on the state of the people, that we're already doing today with terrestrial robots that do chronic disease management. And we're certainly doing them with collaborative robots in factories that work on complex tasks with people. So I would shoot for both. Personally, I mean, it's expensive to send robots into space also, so why not give it function, give it form, and give it a personality that matches both the function and form, and then you have a more robust working group, a more robust social working group.
I think that's an interesting point. You could say, I have her next to me here, so if I say her name, she's going to start talking, but the smart speaker that shall not be named, what is your state of this vacation home in space? And it can talk to you. So having that natural interface is really key. What are some other thoughts from the panel on this question?
Tom, I think that Liesl brought up a really essential element that we're thinking a lot about in our projects, which are the transition states. When you go from people not being there to people being there, you have to realize when the crew is not on board, it's not like there are no people on Earth who are aware of what's going on, but their ability to change the state can be limited depending on the state of communications. And when humans arrive, their expectations will not be met. The first time you go to space, it's not like you think it's going to be. And when people leave, the capabilities that are residual and are still there will be somewhat unpredictable in a learning environment. So during the time that the crew is there, the capabilities of the vehicle itself with its supporting software should improve. So after a decade in space, you know, a smart habitat should be much more autonomous than it was in its first year. So these transitions are critical and a very difficult problem. I'm going to hand this over to Deborah.
Yeah, no, I just want to add from a smart city side, humans are definitely the biggest unpredictable factor of smart cities. And we see this day in and day out. You know, so much of smart cities is not so much about the technology. We know the technology works, it exists, it actually can be scaled. There's some really advanced things that could be done, but how people react to it and deal with it, that's where it adds a whole nother dimension, which is why I said the social infrastructure in terms of how people interact with the built environment, that physical infrastructure, along with the digital environment. That is that layer we don't understand. And I would say, just to elevate it further, you know, there are people in space right now, obviously working, but what if you start magnifying that like cities, when you start having millions of people in cities, each as independent operators doing their own thing, you know, that is where the governance structure gets much more complicated to what is now in space, where you only have a few professionals that have all received lots and lots of training in terms of what to do and how to react and how to respond. You know, when you start scaling that at a whole city level, that is where the unpredictability lies.
Good. No, thank you. Excellent answers. I wanted to ask, what do you see as perhaps the biggest opportunity and the biggest challenge from each of you in your area? So if you just think about what is the opportunity and what's the challenge to get there. And what I'm thinking is that this is a question for all of humanity. This is kind of the beginning of a conversation. There's no doubt that there's going to be a multi-trillion-dollar business here for everybody to participate in all countries. But what should they focus on? What are some opportunities and challenges to go with those? So Deborah, since you're on screen, why don't we start with you?
Yeah, this is probably where I can put my plug in for public-private partnerships. I think that's the big opportunity. And I say this because it goes back to your introduction. Smart cities, smart communities, smart regions, whatever layer or level you want to talk about, it can't be done by any single entity. It's a lot more complex, and certainly they don't have the singular resources, the singular abilities to do that. So that the challenge is exactly that, because you have really complex, unpredictable, and fast moving opportunities and high risk. And so, without any one single entity able to do that, that also presents an opportunity, which is public-private partnerships. So how do you incentivize, all the different entities to complement each other, but also work with each other to leverage their strengths, and help remove the barriers to take it to the next level. And this is where we start to really get exciting things when you talk about shared resources, creative financing, talking about those standards and enforcement guidelines, and start thinking really creatively, so that it's not, that singular identity that we are all rested on. Once you get into those more creative public-private partnerships, you can start thinking beyond your siloed and beyond your box, into greater opportunities.
Okay, great. And you certainly have some experience. You have some well-hidden scars in that whole area.
Scars, yes, I have some scars and trying to do it and keep doing it.
It comes back to the human is the hardest part of all of this.
Exactly.
So how about Steve? What do you think? What's the biggest challenge, and what's the biggest opportunity here, and what's the biggest challenge? Steve Robinson.
Okay. In our world, and trying to envision smart habitats and the technology that'll take us there successfully, we worry about predictability, like all engineers. What's going to happen next, and how can we be ready for it? But recognizing that we will not be able to do that accurately, especially in an environment. I mean, you go to space to do things you haven't done before, so predictability is certainly challenged. So the key is resilience. The key is resilience, and this is where humans excel, and this is where we want autonomous systems driven by software, supervised and trained by humans, to also excel. So that's a major challenge for us.
Excellent. Good. Thank you very much. All right. How about Walt? What do you think?
Opportunities and challenges. So from an opportunity perspective, I really think we should be doing this responsibly. If I could go back 50, 60 years ago and think in terms of responsible space behavior, I would do things very differently. And I think we're just now starting to think about how to do things responsibly in space. So, as we start to lay the groundwork for IoT and connected capability, I think on top of all of that, we should be thinking in terms of how do we do that responsibly. From an opportunities perspective, that's a huge. There's way too many opportunities. I mean, I think you want to make a predictable platform. I think you want to enable capabilities. I think you want to develop standards. I think what you're trying to do from a challenges perspective is, how do you crack those nuts? I mean, how do you make standards that everybody will buy into, or a vast majority will buy into? How do you ensure reliability? Those are the kind of challenges that I think we should be thinking about today. Thank you, though.
Thank you very much. I appreciate it. All right, Mr. Forbes, what do you think? The other Stephen.
So I think that the biggest opportunity is fundamentally that we are early in the stage, right? We have the opportunity to take all the lessons that we've learned from the terrestrial, Internet of Things, the terrestrial networking and everything else, and there's very little truly in the way of completely built out space infrastructure. And so we have the opportunity to take all those lessons learned, apply them such that we can build a more capable infrastructure on our essentially first go around Vice, and then let it grow from there. So we get essentially this running start. And I think that's our biggest opportunity is the fact that there might be thousands of satellites up there today, but the future that we're thinking about is tens of thousands to hundreds of thousands. And going from, essentially low Earth orbit and GEO all the way out to the moon, to Mars and beyond. And so, that the lack of infrastructure existing today is our fundamental biggest opportunity. I think our biggest challenge is, fundamentally space is still a very harsh environment. There's going to be lots of remotely deployed devices. And, right now, a lot of software development relies on the fact that a human can walk up and hit the reset button. Power cycle the thing. And so the harshness of space and the remoteness of space, and the tyranny of distance is certainly as you press beyond the moon's orbit, that's going to be our biggest challenge for how you do that and how you truly take advantage of, the Internet of Things in space. So thank you.
Thank you very much. Great answer. Liesl, can you wrap us up on this question? What are the biggest opportunities and biggest challenges?
Well, if you want to go really big, I think if we pause for a moment and just think about where we are in human history, on the one hand, as I said, we're busy colonizing new planets, but on the other hand, we look at Earth and we're in profound and deep trouble. We are burning. Our forests are burning. Our societies are burning. We're sitting huddled in our homes. People who are lonely and isolated are just not getting the kind of care they need, and that's not getting better as we get older and our health systems collapse. So it's, for me, on the positive side, though, space is an incredible opportunity to really almost, as I said, run this grand experiment. How do we do this right? If we think about our environment, for example, it's the net effect of millions and millions of homes, habitats, with people acting and behaving in a certain way, running their little patterns and habits and interaction with each other. What if we could figure out how to get humans to behave in their habitat in a way that met their goals, kept them happy, but also had minimal impact on the environment? What about supporting people who are in need, people who are isolated or, might be going through the physical kind of stress that astronauts do? Well, here on Earth, 1 in 5 people live with some kind of disability. That's over 1 billion people. My numbers don't quite stack up, but World Health Organization says 1 billion, and most bureaus of census says about 1 in 5. So just like astronauts suffer physical degradation, this is something that's also coming upon us as a species as we age. Loneliness is just profound, and even more profound in the pandemic that we're all living through. 1 in 4 people report being profoundly lonely, and older Americans, it's up to half. It's equivalent to smoking 15 cigarettes a day. That's the impact on your health. These are things around, how can habitat be run as a system using IoT sensors and humans and AI to kind of figure out a better way to do it. Complex task support, and social connection with another that helps bring meaning.
Right.
I think AI are going to make more than half of our home decisions and be about 1/3 of our relationship time and spaces is where we get to play.
Thank you very much. That's great. Great question and great answers. So we're going to wrap up with 30 seconds or less lightning round, where a key recommendation from each panelist. And let's start with Deborah Lamb. Just going to go in the same order we did introduction. So what's the key recommendation to everybody in the audience?
I actually really like what Lisa said was just be kind to yourself. It's a very unusual time right now, so I think this is where we can continue to advance, but it's nice to take a step back and just be kind to ourselves right now.
Thank you. Walt?
I loved it. Smart cities to smart habitats. I think what we need to do is think in terms of security, reliability, capability, enabling what the future might bring.
Excellent. Thank you very much. Stephen Forbes?
So I think the biggest sort of takeaway is learn the lessons from what we've done on terrestrial applications, but don't be rigid and be flexible in adapting them to the space.
That's excellent. Stephen Robinson.
From my perspective, we're tempted to think about autonomy as being able to do without humans. And I see it very differently. We cannot have the autonomy we want without understanding humans and integrating them much better than we have so far.
Excellent. Liesl?
Go out there and do it. I don't know who's listening to this, but whatever organization you're in, space is out there. It's happening. When 2024 happens, it's going to transform how we think. Be part of it.
Thank you very much. And I want to thank the panelists. And my recommendation is that this is the beginning of a conversation. It's this international collaboration and standards is really the key of furthering humanity. So I want to thank the panel very much. This was excellent and really appreciate all your expertise. Thank you.